Hello there and welcome to the Hertford Astronomy Group. I'm Alan Willison, the chairman, and it's my pleasure to introduce this meeting. We do have a slight change of programme, but it is an extra item which I'm sure you're going to enjoy. So let me take you through what's going to happen. But before that, just the usual requests to you. If you've got mobile phones, if you'd like to switch them off. And toilets are just outside and on the left-hand side. We're not intending to practice the fire alarm. So if it does go off, if you would make your way out carefully through the exits each side. Of course, if there's smoke coming from either one of them, choose the other one. What else can we say? First of all, a welcome to those of you on Zoom. It's lovely to see so many people there. We know we've got quite a good audience on Zoom, and it's a pleasure to keep running them. Okay, so what we need the little bit extra this evening, or the programme for the evening, the first thing is you're going to have the unique experience of coming to the Hertford Astronomy Group's first ever extraordinary general meeting. That was because we found that we needed to add a few things to the Constitution, which was written quite a while ago. We have notified you actually twice what those arrangements are. They're all about data security and so on. I hope you've read them diligently. There will be a test on it later on. Oh, I see a few of you looking a little bit worried about that. We did on the newsletter ask if anybody had got any questions, if they could send them in advance so we could get a better answer. So the first question I'm going to ask you is, does anybody on the floor have any questions about the amendments to the Constitution? Okay, and I'm going to ask anybody on Zoom, if you've got a question, perhaps you could type it in. And nothing yet. Okay, you should have typed a little bit quicker. So what we now need is somebody to propose those amendments and a seconder. Proposer at the back, Richard. Seconder, Alana. We now need 2/3 of the members to raise their hands to pass those amendments. So are those in favour, please put your hand up. Fantastic. Okay, hands down. Anybody on Zoom who disagrees, please make your presence known. Okay, well, that sounds like it's being carried, so I'll thank you for that. We didn't anticipate it would take too much to get through, but I would like to say thank you to Tony for drawing up a very comprehensive list of changes that we can now include. The little bit extra I was talking about is that when I finish talking here, Martin is going to give you the talk on the night sky, and following that I will introduce tonight's speaker. Following that, at the end, there will be a chance for you to ask questions. Those of you in the room, you can ask questions directly. Just give us the chance to bring a microphone to you so that the people on Zoom can hear. And people on Zoom, if you've got a question, if you could submit it via the chat facility, that would be really good. Okay, so that's enough from me. I'm going to now pass you over to Martin, who's going to give you a talk about the night sky. Over to you, Martin.
Right, okay. It's a difficult time of year for observing the night sky at the moment because it doesn't really get properly dark. So I've tried to include things that you can have a look at. So this one here is a little brief explanation about noctilucent clouds. Now these are clouds that sit in the higher atmosphere, and as the sun goes down, for us it shines on these clouds and gives these wonderful displays. They're not common, they're quite rare, but if you see an evening where you've got this very high cirrus, it's actually higher than cirrus cloud, it's worth waiting to see if you can get a display like something like that. Be fantastic. So noctilescent means night shining. Now I'm not sure whether that's Greek or Latin, so perhaps learned here may know. It's Latin, thank you. Didn't take Latin at school. We just took fisticuffs, that was it really. Okay, so really I'm not going to talk too much more about the night sky. The only thing I would mention is that we're now in the summer phase. So the three main stars that form the summer triangle are Vega, which is quite high up at the moment in the eastern sky, Deneb, which is a part of the Cygnus Swan, the Cygnus Swan you can see quite clearly, and Altair. So they are worth having a look for at the moment to give you an idea where things are. It's worth noting that Deneb is smack in the middle of the Milky Way as we look at it. So if you want to try doing Milky Way images with your camera, you just need to set it up on a tripod, and if you point it at Deneb and then do say a 30-second exposure, I'm sure you'll see something, although this is depending on your how dark your sky is where you live. So I'm going to be just really talking about astrophotography, as there's not much to talk about the night sky at the moment. And I just thought it was a good idea, because we've got a very active astrophotography section, to delve back through this year to see some of the images and then just give a bit of brief explanation of what you're looking at. So this first one here is of the North American Nebula. I know it takes a bit of imagination. Perhaps I should have rotated it anti-clockwise 90 degrees, but you can see there what looks like the, is that working? No, the Gulf of Mexico there, and that's meant to be Mexico coming down, so yeah, Gulf of America, sorry. That is why they call it a North American Nebula. This here is the Pelican Nebula, but I'll put a bit of brief description there. It's NGC 7000. It is really large. If you could see it with the naked eye, it's unfortunate that a lot of these nebulas are not visible to the naked eye. Our eyes just can't pick up the colours and that a camera can. But this area here is called the Cygnus Ridge because it's all new stars being born here, and that's why it's a brighter section of the nebula, or rift, Cygnus Rift, sorry. I'll go on to the next image. Now this is a fantastic image that Steve's taken, and this is probably one of the hardest objects to image properly in the sky because the central core is so much brighter. This central core here is very, very bright, and the exterior we've have to sort of damp down the central part to bring out the outside part. It's a Wolf-Rayet star, which is a star that doesn't live for very long, burns very hot and bright, and it actually starts to shed off its outer layers before it goes supernova, but they usually do go supernova eventually. So that one there is a magnitude of a plus 11.4, which is not particularly bright, but say the real difficulty there is the central core. But Steve, I think you won image of the week for that one, didn't you, or something, on cloud magnets?
Yeah, of the month.
Of the month, oh wow. So well done. Another one of Steve's here, this is a very much imaged galaxy. It's the M51, or sometimes known as the Whirlpool galaxy. And you can see here it's interacting with another galaxy here, and it's pulling material. So this is the main Whirlpool galaxy, and this galaxy here has been, you can see gravity is pulling material off. So these galaxies will probably combine at some point. It's about the size of our Milky Way, roughly 550 million light years away. This is one I took quite recently. This is a part of the Cygnus Loop, which is a supernova remnant, which happened approximately 2,600 light years. Approximately 2,000. Oh, no, that's the distance. Sorry, it's about 2,000 years ago when this actually exploded. I haven't actually put that on there. That's the distance of the actual nebula itself. If you could see all of it, you're only looking at there the western section of it. But say you could get 4 or 5, well, 6 full moons across there in the sky as a relationship to the size of this thing. But it's it's very dull. It's not very bright at all. Certain parts of it are bright, but very difficult to get everything. We just left the cluster time over through the winter, but this is one of the nicest clusters, M13, again taken by Steve. Again, there's different types of globular clusters and open clusters, and this is a really good example of a globular cluster, which is held together by gravity. So that one, well, it's just saying there's 150 known in the Milky Way. So there's a lot of clusters there, and especially in the winter, you can definitely see these in with the naked eye. Especially M13 is one of the brighter ones if you're in a dark sky area. This one here is the Rosette Nebula. This is a star forming area. It sort of sits between Betelgeuse in Orion and Procyon in the Canis Minor, so it's quite easy to find, and it is fairly bright as well. Steve has done some fantastic images, solar images, especially in May when we had quite a bit of sun, and helpfully there puts a picture. It's the size of the Earth compared to the sun. It gives you an idea just how big it is. But we're in a part of a very active time, 11-year cycle. So we've got a lot of activity and prominences on the outside, and lots of stuff coming to the surface. Lots of material plasma coming to the surface. He's put a bit of information about what he's using there. So quark chromo with this camera there, which is an ASI 174 millimeter camera. Messier 94, the Cat's Eye Galaxy. It's a shame really that the projector doesn't show the detail that you can see on the computer, but it's still pretty clear. You can see the dust lanes of the galaxy there, where the material for the star forming comes from. The red areas are the hydrogen alpha activity, so this is new stars, bright stars. This is a famous picture that I'm sure you'll recognise that Hubble took back in when it first became properly sorted into the image. It's a part of the Eagle Nebula, and famously known as the Pillars of Creation. I took this one, I think, in Spain last year when we were there. But again, there's a lot. You can see the star forming going on there. You can see the stars in the top of the pillars shining brightly. They're just newly born. These stars are probably only a couple of million years old, which in galactic terms are the babies. This is the Pinwheel Galaxy, again by Steve. It's actually a massive diameter, 250,000 light years, twice the size of our Milky Way, and 1 trillion stars. So it is a massive galaxy. Again, this is not an easy galaxy to image. It's not that bright. You know, I found the times I've tried to image it, I could barely get any data at all, but Stephen seems to have picked up a lot of the dust clouds there and the hydrogen alpha areas, the star forming areas. So this is Seagull Nebula. It does look a bit like a bird, I must confess. It's approximately 3,650 light years away in the constellation of Monarchs of Rose, the Unicorn, on the border of Canis Major. So again, it's about 7 times that of the full moon if you could lay the moon out on over its wing pit length. So back in April, I think it was April, we had our partial eclipse. Again, Steve, I think you took this when we were in Kelling, didn't you? So we're in Kelling Heath. So we nearly didn't see it at all because it was quite cloudy, and it was brilliantly clear here. We couldn't believe our luck, but fortunately at the last minute we cleared enough to get an image. But again, you can see how active the sun is there. I think it really shows the activity, especially around the central part. This is another difficult target, the Medusa Nebula. I mean, I did quite a few hours on this and only got that data. So I've been trying to do more challenging targets this year, and that need longer exposure times. But that really only works when we got a fair bit of darkness, and at the moment I'm just trying targets that are a bit brighter. It's just I'm only getting about 2 to 3 hour window to do imaging. This is a fantastic shot. This is the Marca-Haraean chain, and you just realise how many galaxies there are there. Every one of those that look like a star is actually a galaxy, and it just makes you realise how huge the universe is and how much matter there is and how many stars are there. And Stephen's documented some of the galaxies there on their NGC numbers, so about 50 million light years away. That's quite far. Brilliant image, Steve. So this is an image that Michael took earlier in the year of Jupiter, and you can see one of the moons there as well. I think it's Io, if I'm not mistaken. Doesn't say there. But I'm trying to include some images of planets as well. And this is an image by Kevin Noble. And this is a fantastic image of the Pac-Man Nebula. Well, it's only a part of the Pac-Man Nebula. It's where the star formation is going on. It was discovered in August 1883 by E. Barnard. So as he's saying there, in the visible light, or a portion of the nebula is hidden by dust and gas, which makes it look like a Pac-Man's mouth if you look at it from a wider angle. And that really is the contents. Well, thank you very much.
Terrific pictures there. What I particularly liked was when you said sort of how many moon sizes this compares to. It's unbelievable that things up there are taking up so much space and we can't see them. So it's brilliant. Not with the naked eye, you're absolutely right. Now, one of the things that's happened this year was at our public demonstrations, one of the questions frequently asked was, have you seen the alignment? Did anyone remember that earlier in the year? Yep. And as much as we'd like to have said, yes, we can see the alignment, it's extremely difficult indeed. But in 2000, there was another alignment. Whereas this year's alignment had 8 planets in it, The one in 2000, May the 5th, had 9 planets in it. Tonight, you can see the missing planet. This is a plate produced by the Poole Pottery. They produced a series of these charges about the planets because it was such a significant event. Pluto, definitely in 2000, was a planet. So, what happened? To take us on that journey, why Pluto is no longer considered to be a planet, I'm very pleased indeed to be able to welcome our guest speaker, member of the club, Programme Secretary, Publicity Secretary, and probably a few other things in between as well. So please can you give a warm welcome to Jerry Stone. Over to you, Jerry.
Thank you. Okay, so good evening, everyone. The reason that I selected this as my topic for this evening, well, in fact, we were supposed to have David Southwood as our final speaker, but he wrote back to me and said, well, unfortunately, the day before that I shall be at a special event at European Space Agency in the Netherlands, so I won't be able to make it. So I was going to be in April and we just swapped them over. So today, as we're just coming up to the 10th anniversary of the New Horizons flyby of Pluto back in 2015. So I'm going to look at the controversial event surrounding Pluto when its role was changed and so was our solar system. So I'm going to pose and give a definitive answer to the question, is Pluto a planet? Now, I need to make it clear that this is my most controversial presentation. In fact, it includes some material that one professional astronomer has told me I should not be saying. So, on that basis, I feel I need to give this warning. So earlier this year, in February, I turned 70 and I was given a 2-day pass to Astrofest by Astronomy Now. My daughter sent me some helium balloons, so there's a photo of me, and I also have this other one of me with a certain doctor of astrophysics. But I'm going to start the story thousands of years ago when people looked up at the night sky and they could see patterns of the stars, and as they watched them from night to night, the patterns changed position, but they didn't change themselves. The stars stayed in the same position relative to each other. But as they kept watching night to night, they did notice there were some objects that wandered around the sky in relation to the stars. And the Greek observers called these objects wanderers. Except, of course, they didn't, because they didn't speak English, they spoke Greek, so the word they used was planetal. And that's where we got our term planets. Two of them behaved differently from the others. They always stayed close to the sun, and through a telescope, when that was discovered, they showed phases rather like the moon. So it became obvious that they went around the sun, and despite the appearance of the sky, things did not all rotate around the Earth. And as we learned more, we found that the planets all went around the Sun. And we learned that there were Mercury, Venus, Earth, Mars, Jupiter, and Saturn. And these others could all be seen with the naked eye. And that's how things were for many hundreds of years, until with the invention of the telescope, we could see fainter objects. On the 13th of March 1781, Sir William Herschel observed Uranus, leading to its discovery as a new planet, and it actually practically doubles the size of the solar system. Now, Uranus can be seen with the naked eye, and had been seen, but because it's so far away from the Sun, it moves so slowly, it wasn't recognized as a planet. Herschel himself originally thought it was a comet. So, what was the next planet to be discovered? Anyone?
Neptune.
No, not Neptune. The relative distances of the planets from the Sun were all known, and it seemed that there should be a planet in the huge gap between Mars and Jupiter, which I've shown there. So some astronomers started a search for it, and they were referred to as the Planet Police. However, despite their efforts, they were actually beaten by Giuseppe Piazzi, who discovered what he believed to be the missing object on the first day of the new century, 1st of January 1801. The 19th century did not begin in 1800, and the 21st century and the second millennium did not begin in the year 2000, despite what it said on the Royal Observatory Greenwich website, who of all people, I mean, really. Anyway, so the new object was named Ceres. What was not expected was that 14 months later, and at a similar distance, another object was discovered and named Pallas. And then 2.5 years later, they found Juno, and another 2.5 years later, they found Vesta. Now, what's interesting is that at the time, all these 4 objects were listed in tables and books as planets. So including the Earth, this gave us a solar system with 11 planets. With the discovery of even more objects, by 1845, it became obvious that they could not all be planets in the generally accepted means. So they were reclassified, and it was William Herschel who came up with the term asteroid, which means star-like, because even through a telescope they only showed us points of light, whereas the other planets would show a disk. So we went from 8 planets down to 7. So this means we've actually demoted planets in the past. And then in 1846 we did find a main planet, and this was Neptune. This was 60 years after the discovery of Uranus. An examination of the orbit of Uranus led to the opinion that the single body further out could not adequately explain its motion. It was thought that perhaps there were 2 planets that lay beyond Uranus. Further calculations led to a possible location for such an additional planet, and a search was carried out to try and find it. The physical search was carried out in America, and the astronomer assigned to the task was Clyde Tombaugh, seen here with his own telescope. He worked at the Lowell Observatory at Flagstaff in Arizona, and what made his search different was that he was not just using a telescope, but a telescope fitted with a camera. The method was this: photographs were taken on different dates of portions of the night sky, and then of the same area a few days later. And they would be developed and then compared to see if anything had moved relative to the background stars during that time between the two exposures. Now today this would be done by computer, scanning the images and making comparisons of the various dots. But 95 years ago, this had to be done manually by visual examination. And it was done using a blink comparator made by the Carl Zeiss company in Germany. It would hold two images in the form of glass photographic plates, 14 inches by 17. And the user would check the same areas of each, flipping between them to see if anything had moved. So there, in February, Tombaugh was looking at two plates that had been taken on January 23rd and January the 29th. Scanning back and forth between them, he discovered a faint spot here and here. So we can see how much it had moved. And knowing the time between the two photographs being taken, we could work out the speed of this object and therefore its distance. So on the evening of March the 12th, the Lowell director contacted the Harvard College Observatory, and from this officials created the announcement card number 108, which officially announced the new planet's discovery when it was circulated the following day. They chose to announce it on March the 13th because that would have been Percival Lowell's 75th birthday, and it was also the same date that Herschel discovered Uranus in 1781. The announcement was made in the newspapers across America and also in England. This is Venetia Burney, who was born in 1918 and was 11 years old in March 1930. On March the 14th, she was at her home in Oxford having breakfast with her mother and her grandfather, Falconer Madden, who had been the librarian at the Bodleian Library in Oxford at the university. He was reading the Times, as people in Oxford do, of course, at breakfast, and on page 14 he read the news of the great discovery and said he wondered what the new planet would be called. Well, Venetia knew about the Greek and Roman gods, and she knew the names of the existing planets, and after a short pause she said, why not call it Pluto, after the god of the underworld? Her grandfather thought it was an excellent suggestion, very suitable for something out of the deep, dark, cold regions of the outer solar system. And he suggested, he passed the suggestion to Herbert Hall Turner, who had been Astronomer Royal in the past and was a professor at Oxford. Turner also agreed it was a good idea, and he sent a telegram to the Lowell Observatory. Now, when I tell this story in schools, I explain that a telegram was an early form of text message. Anyway, they discussed it, and on the 1st of May, after a unanimous decision, they agreed to use the name. The news was announced and sent back to Venetia's grandfather, who passed it on to her. And to say well done, he also gave her £5. That was in 1930. That's the equivalent of about £400 today. He liked to be generous. The new planet was also given an astronomical symbol, consisting of the first two letters of its name, P and L, which were also Percival Lowell's initials. As a result of the discovery, the solar system consisted of the Sun and 9 planets. And the order of the planets could be remembered by making a mnemonic, if you weren't a nerd like me who knew them. We had Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. So a mnemonic is a sentence made up of words that each begin with the same letters as the initials of the planets. And my favourite was, my very educated mother just served up 9 planets. Perfect, does exactly what it says on the tin. There are other versions. Many vicious elephants munch jam sandwiches, unusually no peanuts. Or many very elderly men just snooze under newspapers. Or one which I use in February in the run-up to St. Valentine's Day, Mary's violet eyes make John sit up nights pining. There's one that you can't really use in schools. Mary's virgin explanation made Joseph suspect upstairs neighbour Peter. But there's one which I do use in schools and goes down very well. My very energetic mouse jumped straight up Nanny's pants. But of course, this one only works whilst there are 9 planets. So we don't have 9 planets anymore. In 2004, out beyond Pluto, we found something else, and another something else, and another, and another. So here are some familiar objects along with some of the new ones. And the one I want you to take note of is 2003 UB313, which of course is not its name. It's a reference that describes when it was discovered. But as you can see from the numbers there, this was reckoned to be bigger than Pluto. So if it was obvious that Pluto was a planet, this would be one as well. This would be the solar system's 10th planet. So we now believe it's very much more similar in size to Pluto, but the question still stands. If one is a planet, then surely the other is as well. And what about Sedna and the other objects? Are they planets or not? How can you tell? Well, you can only tell if you know what a planet is. And it may seem odd, but until 2006, there was no official definition of a planet. Now, many of you will remember seeing astronomy books, perhaps when you were very young, saying that stars, like our sun, give out light, but planets can only be seen because they reflect light. But there was no official definition. So this became a topic for the International Astronomical Union, which is composed of over 13,000 professional astronomers from around the world. Now they have various meetings, but every 3 years there is a general assembly which is held in a different country each time. And in 2006, the 26th General Assembly was held at the Congress Centre in Prague. And the subject of a planetary definition was discussed. Now here's the original version of the solar system, and a new definition of a planet was put forward, leading to a new lineup, which included Ceres, the largest of the asteroids, and I'll explain why in a minute. Pluto, and its largest moon, Charon, and I'll explain that too, and of course 2003 UB313. Now, Mike Brown, whose team discovered it, got quite fed up of having to repeat 2003 UB313 so often before an official name was selected that he came up with a nickname, Xena. And yes, it was named after the warrior princess from the TV show, which is hardly surprising, as after all, astronomers do enjoy observing heavenly bodies. Sorry. So here's the original version of the solar system, and a new definition of a planet was put forward, leading to this new lineup. Sorry, I've gone backwards instead of forwards. Right, so, as I've said, the planets are all named after gods, or a goddess in the case of Venus, with one exception. We have the dullest name in the solar system. I mean, literally, our name is mud. But actually, Earth is the wrong name for our planet. Over 70% of the surface is covered in water, and a distant observer would see the blue part as being prominent rather than the brown part. So if you want to be scientifically accurate, we should name this planet Ocean. How many of you think the IAU are going to change? No, never mind. So on 14th of September 2006, Xena was given the official name of Eris, after the goddess of discord, strife and disharmony, and considering the huge controversy that it had produced, it was the perfect name. So as a result of the new draft definition of a planet, we had a new solar system with 12 planets. So the initial proposal was intriguing. It had some interesting items. The definition read, a planet is a celestial body that is in orbit around a star and is not itself a star nor a satellite of a planet, and it has sufficient mass for its self-gravity to overcome rigid body forces, so it assumes a hydrostatic equilibrium, that is, a nearly round shape. And it has cleared the neighbourhood around its orbit. So if an object met the first two criteria only, but not the third, it would be a new classification of objects, a dwarf planet. This was on the basis that such a body, small body, with low gravity, would not have been able to clear its orbit of other objects. But there are some issues with the wording of the definition. It may appear detailed, but actually it isn't a very good scientific definition. Let's start with the idea of a nearly round shape. How round is nearly? None of the planets are exactly round because of their rotation. Their equatorial diameter is greater than the polar diameter. So how round should they be to qualify? Within 5%? 10%? 15.3%? And what about having cleared the neighbourhood around its orbit? Cleared by how much? By 95%? By 75%? And cleared of what? Cleared of all objects greater than 100 metres in diameter? And cleared to what distance? To within 500,000 miles? 2.583 million miles? These are all man-made limits. Surely we should use ones that rely on the physical characteristics of the object concerned. So we need something defined to a much better degree. Of course, the question is, why was this approved at the time instead of being revised? Actually, there was further discussion during the Congress, and a revised draft was put forward with one very small change in the text, but a major change in the meaning. Watch very carefully. Here it is. In this version, the first criteria is that an object has to be in orbit around the Sun. Only the Sun, not any star in general, specifically our star. Objects that go around other stars are not planets. So that means this is a definition just for planets in our solar system. Why? Well, because there may be planets that do not orbit any star and are just in free space. Okay, I asked. At the time, I said, how many are there? And the answer then was 1, possibly. Well, currently there are many more known examples and suspected examples, but it's an incredibly small number. Do we need a separate classification for these objects? I said, why? We actually need 3 definitions. Planets that orbit our star, planets that orbit other stars, and planets that don't orbit any star. And neither of these last 2 have been proposed. Why not simply say that a planet is usually in orbit around a star, or even overwhelmingly found in orbit around a star? And that would cover all 3 types, and you'd only need 1 definition. So, I also asked, do we need 3 definitions of elephants? Elephants from Africa, elephants from India, elephants found elsewhere around the world. No, they are all elephants. It doesn't matter where they are. So why should any object need a different definition depending on its location? Let's have a closer look at this, particularly the first section. A planet is a celestial body that is in orbit around the Sun and is not a star nor a satellite of a planet. Sorry, a satellite of what? A planet. But you're defining a planet. So that means a planet is a celestial body that is in orbit around the Sun and is not a star, nor a satellite of a celestial body that is in orbit around the Sun and is not a star, nor a satellite of a... So it's a recursive definition, which means that this is a perfect example of the infinity of the universe. Seriously, how did this get passed? Am I the first person to have noticed it? I don't think so. The first person to have come up with a solution? Well, officially nobody else has. How about a planet is a celestial body that is in orbit around the Sun and is not a star nor a satellite of such a body? Nice and simple. I came up with that in about 5 minutes. But they didn't seem to think of it. Why not? And as we'll find out, there seem to be other things they didn't think of. First, here's the vote being taken. As you can see, not all the seats are taken, not by any means. One reason for this is that all Congress votes are always taken on the last day of the event, and by then a lot of the attendees had already left. So instead of 2,700 attendees out of the IAU membership of over 13,000, only 424 took part in the vote. That's 3.2% of the membership. And out of that small number, 237 voted for the proposal, 157 against, with 30 abstentions. So that's just under 56% of those present. So the decision cannot be regarded as truly representative of professional astronomers. Surely for something as important as this, the number in favour should be at least 2/3, and that would have required 283 votes, 46 more than actually did so. By contrast, in 2021 there were reckoned to be about 1 million amateur astronomers. So as you can see, Jocelyn Bell Burnell, who discovered the first pulsars as a student, supported Pluto. So the draft definition suggested the solar system's main objects going around the Sun consisted of 12 planets, split into 2 types of objects: 8 main planets and 4 dwarf planets. The definition and its results may seem fairly straightforward, but they resulted in some questions. First, let's deal with Ceres. The point about Ceres is that with a diameter of 940 kilometers, then Ceres has a mass that is sufficient for its gravity to pull it into a round shape. Fair enough. So it passes the first 2 criteria. It orbits a star and it's round. But it has not cleared its orbit. There are thousands of asteroids in a similar orbit. So but it does meet the criteria for a dwarf planet. The other controversy concerned Pluto and Charon, which, as I said, were included as a double planet. And this caused some members to figuratively throw their hands in the air, saying, "We can't have that." So why was this proposed? Especially when the definition says a planet cannot be a satellite of a planet. Well, the answer is Charon is not a satellite because it does not orbit Pluto. Let me explain. We say the moon goes around the Earth, which it does, but in fact both the Earth and moon rotate around a common centre of gravity called the barycenter. And we can see something similar to this if we look at an athlete throwing a hammer. As he spins faster and faster, the hammer swings further out, and he also rotates around the centre point, not on it. And the Earth and Moon do something similar. In our case, the Earth has 81 times the mass of the Moon, so you draw a line centre to centre, divide it into 81 plus 1 for the Moon, move out 1 unit, and you have the barycenter, which is about 1,600 kilometers below the surface of the Earth. So it is accurate to say that the Moon orbits the Earth. And a similar situation is true for every other planet and moon in the solar system, with just one exception: Pluto and Charon. Here they are to scale by size and distance, something that you can't easily show with any other combination of objects in the solar system. The important point is that Pluto only has about 10 times the mass of Charon. The ratio for the Earth and the Moon, as I said, is 81. So to find their common centre of gravity, their barycenter, you add the ratio of their masses, 10 plus 1, giving 11, draw a line between them, divide the line by 11 and move out 1 unit from the centre of Pluto, and the result is that, strictly speaking, Charon doesn't orbit Pluto. The barycenter is above the surface of Pluto, and both objects orbit this point. But the IAU wouldn't have that. It was pointed out that our moon is slowly moving away from the Earth, and we know this from the reflectors left on the moon by some of the Apollo astronauts. If we fire a laser to bounce off the reflector and time the speed of the laser, the speed of light, which we know very accurately, we can calculate the distance very accurately. And because we've been doing this for over 55 years, we also know that the moon's average distance is moving slowly further away at a rate of about 3.8 centimeters per year. So in the time since Apollo 11, the moon has on average moved 209 centimetres from the Earth. Just over 2 metres. Vast distance. By the way, do any of you know what you have in common with the moon? Well, as I said, it's moving away at 3.8 centimetres per year, and by an interesting coincidence, that's the same rate at which your fingernails grow. But it was pointed out that eventually the moon will be so far away that the Earth-Moon barycenter will be above the surface of the Earth. So does that mean that the moon will become a planet? Well, my reply is, why not? If its circumstances have changed, then why not also change its label? Now, we already do that with other things. For example, when a tadpole loses its tail and grows legs, we call it a frog, even though it's exactly the same animal. In any case, the Earth's radius, nearly 6,400 kilometres. So for the moon to be 82 times the distance, it would have to be 523,000 kilometres away. And that makes a difference of 160,000 kilometres. And at its speed that it's moving away at the moment, to reach that distance will take 4.2 billion years. So my response was, why don't we wait until that happens in order to make a decision on the moon's status? But don't use this as an argument to make a decision about a situation that exists today. They refuse to do that. There is a related point though. If Pluto and Charon had a similar mass, then the barycenter would be halfway between them, and they would be regarded as a double planet with no questions asked. But as the barycenter is out in space, they are a double planet. I mean, at what point does a double planet become a planet and a satellite? As far as I'm concerned, if the barycenter is in space, it's a double planet. If it's below the surface of one object, it's a planet and a satellite. Now we can actually see their movements showing this. This animation clearly shows the movements of Pluto and Charon both orbiting a point in space. But the IAU would not accept this argument. So why not? Can't they understand logic? But not only was this rejected, for no good reason that I can see, but a vote was carried out on the revised definition. A team had worked on the draft definition on and off for 1.5 years, but other attendees thought they could come up with something better in 4 days. And as teachers will tell their students, if you rush your work, you're likely to get sloppy results. Well, we've already come up with several issues. Let's see how many more we can come across, because there are other problems beyond those that I've already mentioned. So a few days after the initial proposal, we had a new version based on the revised definition. And here, with Charon already ignored, and Ceres, Pluto and Eris having failed the criteria of clearing their orbits and designated dwarf planets, we had 8 main or classical planets and 3 dwarf planets. Then in 2008, 2 additional objects were designated dwarf planets, and they were Haumea and Makemake. Haumea was actually nicknamed Santa by one discovery team. Regarding Makemake, David Brown, who led the discovery team, said, in honour of the fact that it was discovered just a few days after Easter, its unofficial name was Easter Bunny. But there are several other candidates, and the question tackled by the Congress was how to classify the increasing number of objects that were being discovered beyond Pluto. One reason was that we might have so many we could finish up with a solar system that could have 50 planets. So what? Many Americans will easily give you the names of all 50 states, and some people will even name their capitals. Why is the number of any importance? Well, one person in complete disagreement with this was someone whose word was taken as the absolute truth for ages. Aristotle, who pronounced there cannot be any more worlds than one, even though he was obviously wrong at the time he said it, as the moon and 5 planets could be seen with the naked eye. Although, to be fair, we didn't know the other 5 were planets. So back in January of 2006, the New Horizons spacecraft was launched to Pluto. A triangular spacecraft roughly the size and shape of a grand piano. It carried 7 instruments, including 3 optical instruments. So in August 1992, JPL scientist Robert Starley telephoned Pluto discoverer Clyde Tombaugh requesting permission to visit his planet. And Tombaugh later remembered, I told him he was welcome to it, so he's got to go one long, cold trip. Tombaugh died in 1997, and a portion of his ashes was carried on the spacecraft. Venetia Burney, or Mrs. Fair as she became, died on April the 30th, 2009 at her home in Epsom, Surrey, at the age of 90, and I visited her grave. This shows Alan Stern, the principal investigator for the New Horizons mission, presenting a plaque to Venetia in December of 2006. New Horizons also carried a stamp originally issued in 1990 by the US Postal Service as one of a series on the planets. The Voyager spacecraft had been to all the outer planets except Pluto. New Horizons would finish the job. David Stern said, Pluto may not have been explored when that stamp set came out, but we were going to conquer that as well. He added, I wanted to fly this stamp as a sort of in-your-face thing. So you may remember car bumper stickers saying things like, my other car is a Porsche. Well, I'm a mission supporter for New Horizons, and my name is on the spacecraft. So I created a sign which I put in the back window of my car which said, my other vehicle has gone to Pluto. Now, I gave this presentation so many times during 2015, the year of the flyby, that I also created an image of a t-shirt listing my tour dates. It was often suggested that I should give this presentation at the IAU at their next General Assembly, due in August of that year. And I pointed out I'm not a member of the IAU, as I'm not a professional astronomer, though I did add I do partially make my living from astronomy. It was then suggested that I could still be invited as a guest speaker. And I replied, this would be very nice, especially at the time the next General Assembly was going to take place in Hawaii. Currently, the next one is in 2027 from August the 10th to the 19th and will take place in Rome, which is a lot easier to get to. So in August 2017, 2 years after the flyby of Pluto, the IAU approved new names for features on Pluto, which included an area named after Clyde Tombaugh and a crater named after Venetia Burney. Pluto's largest moon, Charon, was discovered from photos on 22nd of June 1978 by James Christie, and this is Pluto and Charon from the Hubble Space Telescope. He came up with the name Sharon as a slightly changed pronunciation of the name of his wife, Charlene, with on as in electron, positron, etc. He then found that Sharon was not only a real name, but very appropriately the mythological boatman who ferried the souls of the dead across the River Styx to the underworld, the domain of Pluto. So Christie had his name, one that followed appropriate scientific naming rules while honouring his wife. And Charlene liked to joke, "Many husbands promised their wives the moon, but mine delivered." Now this is a sweatshirt that I bought at the National Air and Space Museum in April 1977, and many of you will have seen me wearing it. This is the front, and here's the back. But it was only earlier this year that I realised that, as you can see, Pluto is accompanied by a large companion. But Sharon wasn't actually discovered until June 1978, 16 months after I bought this. So well done to the artist. So in May 2005, 2 other moons were discovered from photos, and in June 2006, the IAU officially named them Nyx, after the female goddess of the night, and Hydra, the 9-headed underworld serpent in Greek mythology, whose lair was the entrance to the underworld. One reason for their choices was that their initials, N and H, were the initials of the New Horizon spacecraft. So I sent an email to David Stern, who I said was the principal investigator for the mission, and I suggested that if a 4th moon of Pluto should ever be discovered, an appropriate name would be Cerberus, after the 3-headed dog that guarded the entrance to the underworld. And if this should be followed by a 5th moon, then that could be named Styx, after the river that formed the boundary. Well, a 4th moon was indeed announced in July 2011, and a 5th in July 2012. And a year later, the IAU announced their names as Kerberos, with a K rather than a C, and Styx. Now, I can't really claim credit for the names. I thought they were fairly obvious, but it's nice that 2 further moons were discovered, and that both the names that I suggested were actually used. New Horizons was launched in 2006 in January.
Here we go! I can see it!
And this became, at the time, the fastest spacecraft to leave the Earth at 36,400 miles an hour, or 10.1 miles per second. But even starting at this speed, and with an additional gravity flyby of Jupiter to increase its speed, it still took 9.5 years to reach Pluto. This is a view it took of Pluto and Charon in June 2015, 15 days before closest encounter, but you can already see details on both objects. It flew past the planet on July 14th at a distance of just 12,500 kilometers, 7,800 miles above the surface. Its close view of Pluto showed amazing detail. Well, what was really amazing was that the largest shape on the surface just happened to have the appearance of Pluto. Now, I should make it clear that when this character was created, also in 1930, that he was named after the planet and not the other way round. So here's Pluto in rotation in an animation from Hubble images in Earth orbit, giving us the best images of Pluto from that distance. And here's a close-up view in enhanced colour, and a close-up view of Charon in true colour. So here's Pluto with its moons to scale, a family portrait. So Pluto has 5 times as many moons as the Earth. And yet, according to the IAU, it isn't a planet. Having flown past Pluto, New Horizons was able to take photos showing even more details as a result of shadows cast by the sun, and even a view of sunlight refracted around Pluto's atmosphere once it had gone past. And 3.5 years later, on New Year's Day 2019, it flew by the Kuiper Belt object Arrokoth, previously known as Ultima Thule. At 4 billion miles from Earth, this was the most distant encounter by a spacecraft of an object in space. Clearly, Arrokoth itself is not nearly round, unlike Ceres, which is round to within 7.7%. So if Earth was round to the same degree as Ceres, instead of looking like this, it would look like this. Well, perhaps that looks good enough. What about if the limit was 10%? The Earth could look like this and still qualify. But some people might think that's a bit much. So how about 5% of the limit? That would give this, rather than the Earth's actual value of 1/3 of 1%. Earth is about the most round object in the entire solar system. What about Jupiter? Oh no. Would it fit within a limit of 5%? Unfortunately not, because Jupiter does not have a solid surface, first of all. Also, it rotates not in 24 hours, but in just under 11 hours, and it is 10 times the width of the Earth. So as it spins round, its equator is flung out and forms an oval shape. And in fact, anyone can see this looking through a telescope. So if our limit was 5%, Jupiter would not qualify as round. What about the other criteria? How about the third? To have cleared the neighbourhood around its orbit. The idea was that large objects with large gravity, they would clear other objects out of the way. But if we look at Jupiter's orbit, we can see that what they completely overlooked is that an object with high gravity will attract objects into its orbit. In the case of Jupiter, there are 2 main groups of objects based around the Lagrange 4 and Lagrange 5 areas, 60 degrees ahead of Jupiter and 60 degrees behind it. So more than 1 million of these that are larger than 1 kilometre are thought to exist, of which more than 7,000 are currently catalogued. So an object 1 kilometre across orbiting the Earth at the distance of the Moon is 4 times the limit of what can be seen from the Earth. So without telescopes, we'd spot them without any trouble. So this means that more than any other body in the solar system, Jupiter grossly fails this criteria. What does that mean? That according to that definition, Jupiter, the largest object in the solar system other than the Sun, has, as a result of not cleared its orbit, it fails the third criteria, and even though it's 10 times the size of the Earth, this is not a planet. Now, what does that tell us? Does it tell us Jupiter is not a planet? No, of course it is. It tells us that this is a terrible definition. Unfortunately, it doesn't even stop there. Let's come back to barycenters. So each planet has a barycenter with the Sun, but it is below the surface of the Sun, usually close to its center. As a result, it is accurate to say that the planets orbit the Sun, with one exception. Again, because of the high mass of Jupiter compared with the Sun, and also because of its huge distance, its barycenter is above the surface of the Sun, almost 47,000 kilometers above the Sun's surface out in space. That means that Jupiter does not actually orbit the Sun. Both objects orbit this point, and as a result, from a distance, as they go round, the Sun will be seen to wobble from side to side during Jupiter's orbit, a period of 12 years. And we have actually seen this happening with other stars, and from this movement we are able to deduce that they are being circled by a large planet. But as far as this discussion is concerned, the important thing is Jupiter does not orbit the Sun, and that's another reason it's not a planet, because it fails the very first criteria. That means altogether it fails all three criteria. And if that doesn't prove it's a poor definition, I don't know what else would. In fact, there's a real question of why this was approved. Even if we ignore this inconvenient truth, there are still other problems with the definition. I mean, there is actually an extra one which I've only recently thought of, which is that according to the definition, Jupiter is not a planet. So why does the IAU count it amongst the 8 major planets if it doesn't qualify? Never mind. So what about the question of a planet having cleared its orbit? Let's come back to the view of the solar system. So this includes the 2 other objects which have so far been designated dwarf planets, Haumea and Makemake. And let's look at the asteroids that are mostly between Jupiter and Mars, shown here in white. But the orbits of some go further out, even crossing the orbit of Jupiter, making another reason why Jupiter hasn't cleared its orbit. And some go inwards and cross the orbit of Mars, and a similar argument can be made there. But a fair number even cross the orbits of Earth and Venus. In fact, the ones that you might just see marked in red are referred to as near-Earth objects, which number over 37,000. So some of them come so close that they hit us. And although most of them are quite small, some are much larger, such as the one that did so 10,000 years ago in Arizona, or what we now call Arizona. But there are over 200 major impact sites around the world. So it's obvious that the Earth has not cleared its orbit and therefore does not qualify as a planet. It must be a dwarf planet. Now we're now getting into another subject of mine. If you want to know more about the threat of near-Earth objects, you need to book my little number entitled "We're All Going to Die." Anyway, did you know that every day around 140 tons of material hits the Earth? Clearly, the Earth has not cleared its orbit. I mean, either it has or it hasn't. So where does that leave us? Well, here's the new solar system. As per the first proposal, including Charon, but I've also included the 2 additional dwarf planets. So we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, Charon, HAG, Makemake and Eris. But there are, according to the IAU, only 8 planets. And most school books will now say that there are 8 planets in the solar system, even though that's not correct. So my offering as a mnemonic, seeing as I'm not in favour of this, my version evidently might just suggest universal nonsense. But if we restart with the full solar system and remove Ceres, Pluto, Charon and the other official dwarf planets, from the definition we also know that Jupiter fails the criteria, so it must also be a dwarf planet, so we remove that as well. And as many asteroids cross the orbit of Earth as well, that has to go, and they also cross the orbits of Mars, and as we've seen of Venus. And as many astronomers will point out that if Neptune had cleared its orbit, Pluto wouldn't be there. So we have to lose that as well. So that apparently leaves us with a solar system which only comprises 3 main planets: Mercury, Saturn and Uranus. So we need yet another new mnemonic. So unexpected, because of course this is not what the IAU intended, but it's the result of a particularly bad definition, which needs to be amended as soon as possible. Why haven't they done so in the last 19 years? But back in 2006, a number of other objects were also proposed as new planets. And if we only take those that have been given names, that would give us another 8 planets. In fact, Mike Brown, who led the team that discovered Eris, Haumea and Makemake, produced a list of 41 objects that are believed to be over 400 kilometers in diameter and therefore may be in hydrostatic equilibrium, making them additional dwarf planets. So he produced 2 diagrams showing the old solar system and the new one. But it goes beyond this. On Mike Brown's website, he has a page suggesting that as of April this year, there are 10 objects which are nearly certainly dwarf planets, which when added to the 8 main planets would give us a total of 18. There are also 17 objects which are highly likely to be dwarf planets, another 41 which are likely to be dwarf planets, 62 which are probably dwarf planets, and 611 objects which are possibly dwarf planets, giving us a total of 741. Never mind those. The big question remained: is Pluto a planet? Well, it was designated as a dwarf planet, and the IAU said a dwarf planet is not a planet. So what was the result of that? Not only did many members of the General Assembly not agree with this, 157, but so did many members of the public, and they showed it. And there were even cartoons. I like this one. And there were also t-shirts. Right? It's okay, Pluto, I'm not a planet either. And when I was at your age, Pluto was a planet. As an update, how many of you know that a 6th dwarf planet was officially designated, but not until 9 years after the term was first put forward, and 7 years after Haumea and Makemake? It was discovered in July 2015, and this shows its movement over a period of 3 hours. It's roughly 700 kilometers in size, so it will be in hydrostatic equilibrium. It was numbered by the Minor Planet Center in September 2018, 3 years after the discovery, and is referred to as 2015 RR245, but again, that just says when it was discovered. It still has not been given an official name. What has the IAU been doing all this time? It means we can't update the planet list or the mnemonic. But it does mean we now have a total of 14 objects. And this image was taken in October 2020 using the Hubble Space Telescope. But there's a further update. Right? Firstly, this is its orbit, much further out than Pluto. Recently, very recently, 3 weeks ago, another dwarf planet was announced. And it was imaged by the Canada, France, Hawaii telescope in August 2011. Each image is a 320-second exposure taken at 1 hour intervals. But the images were only checked in July 2017, and so it was designated 2017 OF201. With an absolute magnitude of between 3 and 4, it may be the brightest known object in the solar system that does not have a directly estimated size. As you can see, its orbit is extremely large and elongated, bringing it from 45 AU, that's 45 times the distance of the Earth from the Sun, up to 1,630 AU over a period of more than 25,000 years. So, for comparison, Earth is about 150 million kilometers from the Sun. Pluto is nearly 40 times further away at near 6,000 million. But 2017 OF201 is over 2.3 times further than Pluto at nearly 14,000 million kilometers. Astronomers say the next time it will reach its closest point to the Sun is the year 26,186. Don't hold your breath. It's estimated to be at least 550 kilometers in diameter. And it does not yet have an official name, but there are over 1 billion random planet names of science fiction, alien and fantasy to be found at the Planet Name Generator, which I've used to find a few. I'll come back to this. Anyway, so now there are 7 dwarf planets, 8 if we include Charon, which of course we should. So what is a dwarf planet? Well, what's this? A goat? Are you sure? Because actually it is a Nigerian dwarf goat, and under the naming convention of the IAU that would mean it is not a goat, but it is. Then there's also this, an African dwarf frog, which means it is a frog. This is a seahorse, a spider, a beech tree, a hamster, and this is a rabbit. Here we have a honeybee, a minke whale, a rose, and a tiger. The variety of bananas that is the most widely sold all around the world are bananas, despite what the IAU might have you believe. And then there's this. This is a scene from Terry Gillingham's classic film Time Bandits, which features several dwarf actors, including this one, who also played the robot R2-D2 in the Star Wars films. He was Kenny Baker, who I met a couple of times. But basically, despite being a dwarf human, he and the others were still humans. And yet we're told a dwarf planet is not a planet. Why is that? Well, let's ignore the bananas, the tiger, the whale, the hydrangea and the other things. Let's ignore the naming convention used for all science, for all flora and fauna, all the way around the world. Let's suppose that astronomy is special and doesn't need to be consistent with all other science. It doesn't need to follow their rules. So if astronomy says an object is a dwarf planet, it isn't actually a planet. Well, never mind what we're told, because even if astronomy does not need to be consistent with every other science, surely it should be consistent with itself and follow its own rules. So have a look at this. It's a star, obviously. Actually, it's our star. It's the sun. More than that, it's a type G2 yellow dwarf star. So does that mean it isn't actually a star? No, it doesn't. It is a star. There is not a single astronomer, amateur or professional, who will say it's not a star. Not a single member of the IAU, not even one who took part in the planetary vote. All dwarf stars are actually stars. This is accepted within astronomy as a science. And what about this? This is a dwarf galaxy. And so is this. And this. And what are they? They are galaxies. So if, according to astronomy as a science, a dwarf star is a star and a dwarf galaxy is a galaxy, then it's simple and obvious. A dwarf planet is a planet. No questions asked. After all, that's what the term dwarf planet means. It means small planet. If the IAU didn't want these objects to be known as planets, they shouldn't have labelled them as planets. They should have used a different term, such as small solar system bodies. Or how about just a single new word? I came up with one. Hoogly flip. Rolls nicely off the tongue. And if they used that term, these objects would not be planets, they would be hoogly flips. But they are called planets, and so therefore that's what they are. So, with the overall view of the solar system, it would have been simplest to have labelled the planets like this. First, there would be the terrestrial or Earth-like planets. Then there would be the gas or the ice giant planets. Finally, there would be the dwarf planets. So there would be 3 different types of planets, and that would make things very clear, and everyone would accept that without the current huge controversy. Instead, Here's a final problem with the definition, a major problem. Here's a table of the solar system. The important column is the final one, showing the distance of each planet's barycenter from the center of the Sun. And as you can see, the distance of Jupiter's barycenter is greater than the Sun's radiance, which, as I pointed out, means it does not orbit the Sun, so it fails the first criteria. By the IAU definition, Jupiter is not a planet. Now, suppose there was another planet, a large, distant planet, way out beyond Pluto. Its orbit would be so huge it could not possibly have a gravitational effect on every object that crosses its orbit. So that would mean it could not possibly clear its orbit, so it cannot be a planet. It means, of course, no matter what size it is, by the IAU definition, it would be a dwarf planet. But it goes further than that. If we go back to the table, let's give this large distant planet a name, Lardis, and assume it has a mass about 35 times that of the Earth, about twice that of Neptune. Let's also suppose it's at a distance of 6.75 billion kilometers. In that case, the barycenter would be at a distance of just under 710,000 kilometers from the Sun. So it would be 20,000 kilometers above the surface, and it would not orbit the Sun either. So it means that any of the accepted main planets would not be planets if they were at the distance of the Kuiper belt. So if Earth was further out, it would not be a planet. And as I said, the definition of a planet should not depend on its position. So we have various questions relating to the definition. Why did they insist on taking the initial vote? I mean, after all, they vote on things at other meetings. Why a definition just for planets in our solar system? Why accept a recursive definition? Why didn't they think of an answer to that? Why accept Jupiter when it fails all three criteria? Why not accept Pluto and Charon as a double planet? Charon does not orbit Pluto, as I've pointed out. Why are dwarf planets not considered planets when they are? That's what the naming says. Why is Earth and other objects not a dwarf planet when they have not cleared their orbit? Why are planets not planets beyond the distance of Pluto? They would not orbit the Sun. Why is there no proper definition of nearly round? Jupiter does not qualify. Haumea is twice as long in one direction as it is in the other. I wouldn't call that nearly round in the slightest. Why is there no proper definition of orbiting the Sun? I mean, I'm happy to say that Jupiter goes around the Sun, but it does not orbit it. Right? Subtle difference. Why is there no proper definition of having cleared the neighbourhood around its orbit? Cleared by how much? Jupiter doesn't qualify, nor does the Earth. Why are Pallas and Sedna not accepted as dwarf planets? They're both far more round than Haumea. Why did the IAU accept such a badly written definition? And why has the definition not been amended in 19 years, considering the huge controversy that it created? The result is that the IAU looks foolish, and this downgrades its reputation. But the main point is with regards to the main question, and the answer, thanks to the IAU definition and what it actually means, is clearly yes. Pluto is a planet. And we don't have 8 planets in the solar system. Pluto is one of the 16 planets. In fact, in view of the very recent announcement and what I told you this evening, I may be the first person to announce in public that the solar system has 16 planets. Why do I do this? So I can let others know this information that I have gathered, even if it goes against established thinking. And I think an appropriate quote describing this reads, "Know the rules well, so that you can break them efficiently." And that's a quote by the Dalai Lama. Thank you very much.
I'm sure you'll all agree that was a fantastic talk, wasn't it? I'm also pleased to announce that Poole Pottery got it correct, because they also made a plate of Sedna. So good for them. Yes. Right, I'm sure we're bound to have a few questions, so if you have a question, put your hand up, I'll bring the microphone to you. Don't be shy. Anyone on Zoom, you can send questions in via the chat facility. We've got one there already? Okay, let's start off with that one.
Right. This is from Peter Jenkins. What has logic and sound judgment got to do with the IAU decisions, compounded by a dubious voting procedure? Humans are fallible, gullible creatures. Sorry, this is an essay. Prone to groupthink and hate to lose face. Humans have a very strong survival instinct. How would you vote against other IAU members who indirectly fund your employment or could influence your career prospects? So 2 questions for Jerry. 1, is there any motivation at all in the IAU to first define robust decision-making process to represent the views of the majority?
There darn well should be.
And 2, who would benefit or lose if Jerry's proposals were to gain acceptance?
Okay. Millions of members of the public would benefit, as they believe that Pluto is a planet. It's a question of understanding things and describing them properly. This definition does not describe the situation properly, and it should be amended. And as I said, the question is, why hasn't the IAU done so in 19 years, when they know how much this has stirred people up? I mean, if we made definitions in biology that were incorrect, there'd be a whole load of people who say, no, I'm sorry, but I don't trust you if that's how you're going to act. And this definition does make the IAU look foolish. And the thing is, they can do something about it. One of my other questions was, why did they insist on taking the vote at the Congress? They could have and should have said, this is obviously something that needs a lot more discussion. Let's take the time to do so. And we can decide at another meeting, or even at the next General Congress in 3 years' time. Let's not rush things now. There you go.
Any questions from the floor?
All the planets are there and they're all visible. What difference does it make?
Well, as I said, it's a question of being able to define things properly. That's what all of science is about. You make observations, you come up with a theory, and the difference between a theory and a claim is that a theory properly describes the situation, and as a result you can make predictions from that theory. And if any of the predictions turn out not to be true, then the theory is wrong. Right? That's basic thing of science. And we should describe things properly. And the IAU has not done so. At the front.
First of all, I'm going to make the assumption that you would be happy for your definition to apply to exoplanets as well.
Yes, if you say that a planet is a celestial object that is usually or overwhelmingly found in orbit around a star, it doesn't matter what star it is.
Thought you said. So my question here would be, how would you deal with binary stars? Because if the we know where the barycenter of the binary star itself is, but at what point does it cease to be within the star?
So with binary stars, if you're talking about them and no other objects, then one of those will not be a planet. Right? If one has a much, much greater mass than the other, so it goes around it, I mean, both of them will still go around a common centre of gravity, but they are both stars. And perhaps that should be included in the definition. A planet is a non-luminous celestial object. You know, there are all kinds of tweaks that can be given, but as for planets that may rotate around a pair of binary stars, they would be so far away that it would be effectively as though there was just one.
Thank you.
Is there anybody else who'd like to ask a question? Yep.
Yeah, you just said that it would be a non-luminous. The Earth glows massively at about 10 microns.
Ah, yeah.
So you'd be very, very careful about that one.
Yes, I mean, do we have to limit it to radiating invisible light, whatever? You know, I mean, it does need more careful discussion. Yes. All right. A celestial object that does not create light by fusion energy. You can see the definition is growing.
Are there any more questions?
Yeah.
Any more on the internet? No. Okay, well, I'm sure that you all found that absolutely fascinating. From start to finish, you covered such a controversial subject extremely clearly. I can't see how they could ignore your requests to redefine it, and let's look forward to that happening quite soon. I'm sure we'd all like to say thank you very much indeed to Jerry for presenting such a reasonable argument about why planets, or particularly Pluto, should be redefined. Thank you very much indeed, Jerry.
Thank you.